What a lovely day to everyone! I am Irvin Embalsado, and I just had bacterial bronchitis a few weeks ago. Just like me, several people have experienced such diseases before, where pathogens and toxins attack our healthy cells and we try to cure ourselves with medicine. We often take antibiotics that attack the bacteria in our bloodstreams, but more and more strains of bacteria have been developing antibacterial resistance. One of the most well-known examples is methicillin-resistant Staphylococcus aureus or MRSA, a strain of bacteria that resides in a person's nose, throat, or skin and can cause severe diseases that have proven to be fatal. This strain has multi-resistance to modern antibiotics, and eliminating it in a person's body becomes a challenge. However, there is a recent innovation that may be able to solve this problem: gold nanorobots that disguise as somatic cells. The nano-engineers at University of California, San Diego have designed these nanorobots that are composed of acoustic gold nanowires covered with biological coating. The membranes of red blood cells and platelets are fused to form a dual cell vesicle that is able to neutralize toxins and bind bacteria. The surfaces of the synthesized gold nanowires that are 1.5 to 2 microns long are augmented with methiopropamine to allow the dual cell vesicle to latch onto the nanowires. The researchers exposed these nanorobots to an acoustic field for 5 minutes before injecting these nanorobots into test tubes containing MRSA and a red blood cell solution, where ultrasound propels the nanorobots to increase the rate of collision and binding with the poroforming toxins and MRSA. The purpose of these nanorobots is to serve as a decoy for the pathogens to attack instead of the actual healthy human cells. Their experiment has shown that the rate of hemolysis, or the damage and rupture of red blood cells, is significantly reduced when the nanorobots were introduced into the system, and even more so when they were propelled by ultrasound. This means that the nano-engineers at UC San Diego successfully made the MRSA target the nanorobots instead of the human cells. Now, what sets this innovation apart from the technology already familiar to us today? We may have heard of drug delivery using metal nanoparticles that are directly injected into blood, which may be similar to this gold nanorobot innovation. While that is preferred for easier to treat infections, the gold nanorobots are better used for the most harmful antibiotic-resistant bacteria. Another standout characteristic of this innovation is that it uses ultrasound to accelerate the nanorobots instead of fuel because, unlike nanorobots, fuel can be identified by the body as foreign substance and may cause further complications. Also, the membranes are dyed prior to the coating process so that the movement of the nanorobots can be tracked and observed during the experiment. Because the innovation is still in the early stages of its development, it currently doesn't hold a patent grant. However, there are relevant patents that make use of similar technologies used in this experiment. These patents include the synthesis of nanorobots for drug delivery and the use of ultrasound for kidney stone removal. The next step for this innovation is in vivo experimentation. Mice can be used as the living organism where the nanorobots and MRSA or other antibiotic-resistant strains of bacteria can be injected. Performing such an experiment will also require the use of a mechanism for removing the gold nanorobots out of the bloodstream. One way this can be done is by adapting the technology from drug delivery nanoparticles, where a chip containing tiny electrodes that generate a rapidly oscillating electric field can isolate the nanorobots from the blood plasma. The chip may be attached to a tube where the nanorobots can exit from the bloodstream. This coating technology of this innovation may also be used for other potential functions, such as coating nanowires with membranes of dead pathogens for a rapid vaccination process, or for targeting diseases that occur in specific organs. This innovation has proven to be promising and is definitely one to pay attention to while it is in its development process. Here are my sources, and I thank you all for listening.